Hi everyone. Hi, I am Libertino Felani Sarmento. I'm from informatics engineering in the first semester. So these presentations I will share my presentation explaining about the all the essay including in the essay including in the final exams. Okay, so we skip now. So we will start now. Okay, we talk about table of contents. Table of contents first we speak about the binary cell. Second about bubble sort. Third is quick sort, and four is about tree. And the fifth is graph, and the sixth is conclusion. I'm be explaining about that. Okay, so we will start now. First is binary sets. Binary sets. Binary sets is about the algorithm. Yeah, it's about algorithm settings or setting algorithm to find it the element positions to positions in the sort array. And then how to in the middle of positions the set binary set it can implementing only so the list or element not sorted already, but we need to show how to binary set to improve. Like when you created a binary, you know how to be see the binary set in the position element in the position element the middle of number or the middle of the point that you can element is always be in the middle, yes or no? Because binary set is always in the middle of portions together a point to be sorted or array. Alright, we go to the next. How to binary set work. Binary set work. The first is initiative point. Okay, initiative point. Low and high pointers. Low and high pointers. Start the array. How to be get the point in the end, in the start and end of the array. And the next is calculate the middle that. When you get the middle of the point on the number of the point, element the array, the middle. And the third is compare with the target. Yeah, the middle element is equal target to set in successful because the middle of the number target is set of the successful at least the rest of the middle element the half or less, because when the number is low as we see with the point that we go on the rest based on the comparisons, because comparisons repeat the process and continue the form repeated stand by until the number we can get, because the middle if we get the target we found that point or surpasses the highest of point. These are the point of number. So guys, I will give an example about binary cell. Okay, this is binary cell I will explain. Okay, I will go to the Python cell. Okay, so this binary cell you see this binary cell, and low 0 and high rank 1. So sorry, I'm missing this one. Okay, even and then this about the best example. And now okay, this about the point array. This example I put 10, 15, 20, 25, 13, 13, 5, 14, 45, 15, and the x I put the 13 here, Okay, this also will be used as and also will be element is present at index. Yeah, this is just a number. Yeah, at array. Okay, okay. So we know. Okay, this about the example I will be learn and as we see the result here. This result here. So okay, I will read it now. Alright, you see, element is present at index 4. Why we put the 4 here? Okay, because as we see now the example that how is working when this serve example here 10, 15, 20 in this bubble and then because this is 0, we start for the 0 until 0, 1, 2, 3, 4. Okay, this is 4, 5, 6, 7, 8. Okay, this is 4. We start for the 0, 1. Okay, this is 4, x is element is present in that 4. Okay, we see the 4. Okay, that's it. I think that's enough. Okay, this example about the binary cell. Okay. So we go to the second type of content, bubble sort. Bubble sort is a sorting algorithm compared to agented elements. Yeah, I think bubble sort is algorithm. So is sorting algorithm. Sorting algorithm that until they will never enter the order because algorithm bubble is moving water in the rise up, suffer the element, and then the bubble sort is created almost. And how to get the compare the agent elements, the two elements, who the near the element others. Some other contents, bubble sorts, it pulls or suffers its element array moves to the end its iterations. We can call the bubble sort because the two elements between that element, sorry, not between, but two elements compare the two elements. The two elements start in the middle, in the left and right. And the end or star, we can cover the rise and the rise up and the end of shuffle. Element we can call the array the bubble sort because they want to know how the element can move on to the end until the end iterations. Therefore, we can call the bubble sort because they compare two agent elements swap then until they are in the order until they rise up to move on the move iterations or bubble elements. Next I will explain about it. Okay. Now we're going to how bubble sort works. Okay. Bubble sort works start from the beginning on the rates. Yeah. And then so start from the beginning at the rates. So compare first two elements if they are in the wrong order swaps then move to the next page or element repeat the process until the end of the rates. After the first pass, the ranked element is guaranteed to be the end of the race. Repeat the process to remaining element, including the last one until the entire race. So this here are the bubble sort of. I just give you spin. Just make sure that when you start how to see the bubble sort start the work, you start for the beginning and the rates, and you will be compared to the elements. If they one or then one, you just swap them and move to the next stamp. Just repeat them and on the process until the remains the end of the race. They repeat the process to remind that and to add that to include the last one. This would meaning that how to the rest of the subs they must be repeated process included the last or the end of the bubble sort, repeat the process until the first pass and the last will be granted the rest, and now the repeat or sorted. And this was the water bubble sort work. Okay guys, I will explain now we go to the example for bubble sort. Okay, this bubble sort, as you see, bubble sort. Okay, this some example on in the Python. Okay, this is bubble sort. As you see, bubble sort they define the two element adjustments. They compile the two elements, right? Okay, the two elements. Compare two elements. Here go now. You see this some the data. I put some negative 4, 18, 5, 0, 25, negative 10. This is an example. Okay, so I will delete that. Okay, we repeat that. I will explain about that. Okay, this some of example in the Python in bubble sort. This all about the bubble sorts. The coding Pythons. So okay, I will keep on solve. This is as you see. Okay. Alright. This okay. Why the sorting array is ascending order? Okay. This why the sort here is negative 10, negative 4, 0, 20, negative 25, 18, 5. Okay, why the sort like this? Because as you see the compare to the two elements, this is two elements. Therefore, the right is positive and the left is negative. This is following the, because as you see this random. Okay, this random elements, the number random. Okay, the data, and now the following that to compare. Yeah, this is about that. So bubble sort is called about this. Okay, the compare two elements. Okay, this about bubble sort. Okay, so I think that's enough example. And next we go into the okay, again this was the bubble sort. Okay, I think that's enough. Next I will explain the third material is about the quick sort. Okay, the quick sort is algorithm the sorting algorithm based on the divided and concrete approach the where alien is divided into this separate by selecting the pivot element select from the array. Okay, when you know about the quick sort, when you remember the quick sort is that it's a sort algorithm, but quick sort is different with the binary set and bubble sorts different, because quick sort is just divide the arrays and pick up the elements to be positions such as element rest the people keep the one red slide and element granted are process a right side of the people. The left and the right separate the divide use the same improvement to the process of the continuous until the other one software contain a single element at the point element is already be sort finally and used to be create on set or sort again. Quick sort is just based on the divided to divided element could be popped and quit. Pivot and quit sorts divided selecting by the pivot element. And then element at least then pivot keeping the red side and the element are greater than the right side address is very as the reset, keyboard and anti-death continues the sub-array to be single elements. This was you know how to be combine them. Quicksort is very usually to divide the array into the sub-array and pivot elements. So we go to the next how the quick sort works. Okay, the quick sort works. The first choose the pivot element from the array, and second partition the array into the two sub-arrays. Element less than pivot the element greater than pivot. And third is a Xavier apply the quick sort to the two sub-arrays, and fourth combine the sort sub-array passing the pivot between them. This is why the words so work. You can see that. Now, so guys, we're gonna go into the example of quick sort. Quick sort we going to example. Example is okay. This example of quick sort. This quick sort, right? This example quick sort like this, as you see. Example like this. This about pivot left middle right. This the about the pivot as we speak right now. We going to okay. This is an example. I put the 3 seat 8 10 1 2 1. Okay. This solve is original with my soft reads. Okay, as you see. Okay. Now we're going to go into the solve. Okay, I can now. Okay, as you see this original leaf, right? You see original leaf here. The original is 3 6 8 10 1 2 1. Okay, now we're going to the short hits. Okay, short hits is the first original is random, as random is like random number of elements. Now we change the short hits is 1 1 2 3 6 8 10. This like for the short hits or quick sort. This okay. These are short hits. Okay. I think that's all the example. The fourth statement is the T. Tree is a hierarchical data structure that consists to nodes connected by edges. Okay, tree is a meaning how the structure that the data structure the hierarchical. Alright, in the concept of computer science, we used to represent the hierarchical in the relationships of that old data structure in the street. The node has the parents, like we created some data structure, the hierarchical, because the industry like we can combine it like the family like that. In the family of parents, and still each another have a parent set the roof. Like we make some like parents, we made the roof for noodles, 0 more on child noodles. There are more like now that's the 3 we can create a data structure from the 0 and more the child. This was the point we can know about the 3. Alright, this about the 3 work. How 3 work in this session. Yeah. Okay, first is 3 start with the root node. And the second is each node can have 0 to more child nodes. And the third is nodes with the same parents are considered siblings. And for the last level of noodles with no chai are called reef. Okay, this the word how to the treat. We see the first is we can create the root node, and the root is if root node have 10 or more child node, they more the same parents, are considered the same beings. If you see the last or the point or the level or noodles with not the child, they can ref or they can live now. This is what we can consider the tree. Wow. About the 4 sessions. Wait a minute. Okay, this example of the tree. Okay, the casting note. Okay, the on the coding, right? The coding speaking about how to in some structure in the parents. For instance, starting 0, right? Like some tree, tree, like make some tree for the child. Start this tree from parent to the child. Okay, 0. Start for the 0 until the child. Okay. This is our roof, right, reps, and the thing no 1 until it's 5. The print the tree each order. Okay, in all types of Lebanese tree. Okay, I will explain as I see. This about coding some example. This some example. This example. Okay, use agent. Okay. Now we go to the show. I will run now. Okay. Okay, you see that in all the types of the binary tree, 4 2 5 1 3. Okay, because for as you see the roof. Okay, the roof reps. Okay, for the rep to the rep and roof 1 and 5 roof reps right and 1 and 2. Okay, for the is following to the tree for the parents. Okay, exactly this parent is here as you see its parents. If I change this order, because for is following for the roof, you see the contrasting a simple binary tree following this one. Okay, it is very, and that's exactly the result of this one. 4 2 5 1 3 is okay. I think this of the example if you understand. Okay, is understanding. Okay, thank you. I think that's all. Now stop. So next the last one we can talk about the curve. Curve is a collection of nodes, verticals and verticals in edges that connect page or nodes. So curve is some vertical size data structure. It's collection about the nodes. It's about the nodes collection of nodes. The edges connection by nodes. In the curve, nodes is represents relationships between the two styles, and then nodes curve is a data of using to modest values. The modest values in the relationships between the objects, and in the curve, nodes is entire or represents every relationship between the touches. This is about the curve. Curve is the meaning of correlation of nodes and represents between the relationships in which object in the object. This was represents relationships between the two or structures. These are meaning for the curve. So guys, now we're going to explain about the example of curve. Okay, curve is you explain about the curve. The curve, as you see, the vertices, edges, and pin curve. Okay, the vertices, as you see, this the curve defined for this one, and okay. Now we put some example. Okay, this example I put here. I put for the my curve. Okay, the 1 2 3 4 these vertices Yes or no? Okay. Now the etcher. You know etcher? Okay, etcher. As you see, 1, 2, 3, 2, 3, 3, 4, 4, 1. Okay. This is about the example and the print the curve. The curve is I put the graph representations. Okay. Okay. This as you see. Is some example here. Now we're going to see the result. Now we run here. Okay, you see the graph repetition 1, 2, 4. This is vertical, right? This is vertices, and the hatchet is the edges. Okay, these are result representations. Okay, as usual, these are all about the example about the graph. For with the relationship with object, right? For about a structure, this the curve relationships with the object and the answer here. Okay, this okay, this about the example. Okay, now this end about the example, and that's all enough. Okay, this about the example. So in the conclusions, I will make conclusions. In the conclusions, just I writing so long, but just use as you see the conclusions in the presentation. We compare the key algorithm in data structure use Pythons, right? Banner search and bubble sort, quick sort, trees and graphs. These are meaningful all the conclusions. But this concept, Pythons are fundamental problem solving that optimized solutions. As you, I hope that conclusion is meaningful for all of you. Thank you. So that's the end of my presentations, and thank you for understanding my presentation. So I'm really apologize if my English is not very good for all you. So I'm very sorry about that. So I hope you can get all my points in the presentation. And so that's all, and thank you. Bye.